So in this mini lesson today, we're going to consider an example called a spoonful of sugar. That's a linear equation representing a real-world situation. And here we're told that a ceramic sugar bowl weighs 340 grams when it's empty. Then we start to fill it with sugar. 1 tablespoon of sugar weighs 12.5 grams. So we're asked in the first problem to write an equation to represent the relationship between the total weight of the bowl in grams, and we're going to call that W, and the tablespoons of sugar, or T. Now, we know we've been writing these linear equations like this. Y equals mx plus b. We call that slope-intercept form, where we have a rate of change, and that's our m, and then an initial value that we represent with b. So let's go with that slope-intercept form. I think that would work well here. We have W that represents our total weight of the sugar bowl. And then we know that in the beginning, the sugar bowl weighs 340 grams. They tell us that. So it's got to at least weigh 340 grams. And then every time we add a tablespoon of sugar, we're increasing the weight by 12.5 grams. 12.5 grams, 25 grams, and on and on. So every time we add that tablespoon, we increase the weight by 12.5 grams. So that's a nice equation. I think that would work. The weight of the sugar bowl plus the weight of the tablespoons of sugar. Now I'm going to change it around. I'm going to put the 12.5 first, just because that makes it look more like y equals mx plus b. We have our slope, and then we have our initial value. Okay, that's our equation. Now the second question asks, when the sugar bowl is full, it weighs 740 grams. So they want to know how many tablespoons of sugar can the bowl hold? Well, in this case, in our equation, that we're told that the total weight is 740 grams. So let's just put that in for W for the weight. And here's our equation that we already worked hard to make. And we can solve that equation. This is a simple one. We know how to do this. We've been doing this since the beginning of the semester. So if I subtract the 340 from both sides, I end up with 400 equals 12.5t. And then to find out how many tablespoons, I need to divide both sides by 12.5, which gives me 32. So now I know that 32 tablespoons of sugar will fill up this sugar bowl. And the third question, we're given a graph that represents the relationship between the number of tablespoons of sugar in the bowl and the total weight of the bowl. So first it asks us which point on the graph could represent your answer to the previous question. They're talking about this answer here. So 32 tablespoons. Let's look down here on the x-axis because that's where our tablespoons are. If we find 32, it's going to be like right about here maybe. So if we go up, we're going to end up here at point D. Well, if we go across, that looks about right. Our weight is about 740 grams. So that's the point, that represents the point that the solution that we came up with in problem number 2. So a graph is very useful because we can figure out how many tablespoons of sugar will make the sugar bowl weigh any weight using this linear equation, or using the graph of the linear equation as well. So question 4 asks about how many tablespoons of sugar are in the bowl when the total weight is 600 grams. Now we could put that in the equation. We know how to do that, but we could also use the graph. Let's see if we can find that point. 600 grams, we're looking on the y-axis, so let's see, 400, 500, there it is, 600 grams. So if I go across, now I want to find out how many tablespoons of sugar, so I'm going to go down, it's close to 20, it's a little more than 20, and I actually plugged it into the equation earlier, and I got 20.8. You can check that out. But we could also get that from the graph. We know that 20.8, or a little more than 20, or almost 21 tablespoons would make the bowl weigh 600 grams. All right, this problem is actually one from your assignment today. So I'm about to give you the answer. So I'll be able to see who watched the video and who didn't. It says a baby pool holds 120 gallons of water. John drains the pool at a constant rate of 6 gallons per minute, and we're told to write an equation to model the situation. I wanted to show this one because it's a little bit different than the first one. We're still using y equals mx plus b. Okay, and then we know that our initial value or our starting point is 120 because we have 120 gallons of water in the beginning. So I have y equals, mx plus 120. The thing that we have to consider here, though, is that the water is decreasing in the pool. He's draining the pool. That means the water is pouring out of the pool. So they tell us that our rate is 6 gallons per minute, but we have to make that a negative because the water is draining, because we're decreasing, not increasing. So y equals negative 6x plus 120. And then the second question asks, how long will it take for the pool to be empty? Well, y in this case equals the amount of water in the tank, and Ms. Holt should have defined her variables to begin with. Water in the tank, and then x is minutes, the minutes that pass by. So how long will it take for it to be empty? We're looking for minutes. We know that the amount of water in the tank would be 0 when the pool is empty. So 0 equals negative 6x plus 120. And then we can solve that. Let's add the 6x to both sides. 6x equals 120. Then we can divide both sides by 6. X equals 120 divided by 6. So that would be 20 minutes. All right, so nobody should miss this one on the Go Formative today.